Well, thank you, Lutz, and good afternoon, good morning, wherever you are to this webinar. OpenEdge Application Refactoring with the Smart Component Library. What I'm going to do in the next hour is to start by giving you a brief overview of the Smart Component Library framework for those who haven't seen it, or haven't heard about it yet. Then I'll be discussing and showing some ways, some techniques that we use in modernization projects to actually migrate existing applications, bits of existing applications into a new structure that fits in the Smart Component Library. I'm not going to promise you the one-click button where you take an ERP system and 2 minutes later everything is converted. Pretty sure that would be possible or desirable, but within the Smart Component we have tools that at least make the journey easier. I'm going to show you some of those. The samples may seem quite simple. It's always the thing with these demos, whether you use very complex samples, which probably would take quite long to explain the plot, or whether we just show a series of simple ones that can then be combined into something more complex, and I've decided for the latter. Good. Yeah, my name is Mike Fechner. I'm the founder, director at Consulting Werk, responsible for the business, but also involved in the technical side of the company, and especially as the product manager and architect for our modernization products like the Smart Component Library and the WinKit. But I also work with customers as an architect in modernization project. I'm using OpenEdge or Progress at that time since quite a while now, started procedural like probably most of you on this call, but since Progress allowed us to use object-oriented coding, I've quickly adopted that, for many reasons this has become my preferred way of coding. I like to deal with software architecture. I mean, software architect, that's what I should be doing. I'm fairly sufficient with desktop user interfaces, especially the .NET side and the classic Progress GUI. And I think I know enough about web technologies, and especially the Angular framework, to ask nasty questions to our specialists there, and ask even more nasty questions when I do the code reviews there. We at Consulting Werk, we support companies that use OpenEdge or companies that develop with OpenEdge. The development side of things is really our special area. If customers are seeking assistance more on the operational side of an OpenEdge application, we would be referring them to our partners. Our team is spread across a number of countries. Our main office in Cologne in Germany, with subsidiaries in the United Kingdom, USA and Romania, developers working from home offices in Czech Republic and in the Netherlands. And from there, we're serving our customers, mostly all across Europe, Northern America, Australia, and Southern Africa. We provide developer tools focusing on OpenEdge and consulting services to our customers. And all that typically in the context of an modernization project. There are other services, or the wide range of products from Progress Software that we deal with. I'll leave this standing and quickly go over it. And non-Progress Software products which have some value, some relevance for OpenEdge developers. So the agenda for today, I'm going to start with an overview of the Smart Component Library, talk a little bit about the backend, but only very, very short. User interfaces, our repository-driven user interface approach, and then go into 3 specific use cases where we migrate existing OpenEdge applications into structures in the SmartComponent Library. Start by doing an old TTY style update editing statement or update editing block, which without manually changing any code, I turn that into a RESTful service. Then I migrate UI layouts. That's typically more something that we do with customers that start with a GUI. Also, we can also do it with TTYs. And then looking at migration of trigger logic. I think with that, I have 3 very typical use cases for dealing with existing application code and integrating that in the SmartComponent Library. Yeah, so at a glance, the SmartComponent Library is a full stack modernization framework or developer framework focusing on the modernization of applications. Full stack means we have a backend and multiple front-end options. The backend can be used by zone. We have customers that use the backend of the SmartComponent Library in a headless fashion, without any of the user interface components that we provide. And we have customers that use the backend together with one or multiple of the front-end options that we provide. We put a lot of focus on the backend. That's where all the business logic should reside. And that has a lot to do with my experience of, well, over 25 years supporting other OpenEdge developers in building applications and seeing what is changing on the front end part of things. I truly believe that in 10 years from now, we're still going to be looking at an OpenEdge backend which is compatible to the codes that we're doing now, and probably still using an application server very similar to the application server which we can be using nowadays. I'm not going to tell anyone what will be the state of art in front ends in 10 years. So front ends come and go. I think the backend is a much more constant asset in an application, and the period in which front-end technology change is accelerating still, and so I think as an application that wants to be future-proof, it's very important to be able to replace the front end or support multiple front ends in parallel for the same backend. In the backend, when writing application logic, we're using OpenEdge. OpenEdge is specialized on relational structures, but also allows us to use object-oriented structure. So we support a relation way of dealing with data in the application, or an object relational way through mapping the relational structure into objects. A lot of that is supported by our code generators and graphical designers for backend components. And I think it's very powerful for our customers to be able to use both. We use, we support RESTful interfaces out of the box. That has become a very important component for many of our customers. It's very easy. And I believe with the SmartComponent Library, we provide the simplest and most powerful option to build REST services for, or especially RESTful services for OpenEdge. And I'm going to touch that a little bit in the first of my demos. Like I said, we support multiple user interface options for the desktop and mobile. I'm going to talk a little bit more over that in a couple of slides. Within the framework, we distinguish between purely architectural components and application framework components. So things like localization, so translation and others, menus, workflows, scheduler, etc., are for us components of the application framework that's optional to use. We have customers that just use the architectural components. So that's actually two components in the product where the one is built on top of the other, and the purely architectural components can be used all by themselves. The framework is designed to integrate with existing OpenEdge applications. Typically, when we do modernization, we don't start on a green field. We always have an existing OpenEdge application that has been grown and might be based on a framework from a third party or developed in-house. So it's a common requirement that when we introduce a smart component library there, we integrate with that. We provide the full source code of the product to our customers with the right to make modifications to the source code. We provide new versions of the framework, sometimes weekly, sometimes bi-weekly, sometimes monthly. Whenever we have something relevant enough to ship, we can just hit the button and ship it. In the release process of the smart component library, the most complex bit in the whole process is actually writing the release notes. That's not really something that computers can take away from you, maybe in the future, but not yet. That's sometimes what's stopping us from releasing, not on a daily fashion. DevOps is an important part of the product or the scene where we're using the product. We have templates for build, test, and deploy scripts or routines. Currently, we support the framework officially on the 3 LTS versions, so 11.7, 12.2, and 12.8. What that means is we make sure that all features work on all 3 OpenEdge versions, and we test that and are able to support customers when they run into issues there. Application framework mentioned a couple of those features earlier. I'm gonna jump over that. So backend architecture, very important piece of the product. That's what allows us to reuse the business logic in different environments, and I believe an important part of being future-proof. We support service-oriented architectures following the OpenEdge reference architecture, the common component specification. We have tooling support for the development and of the typical components of those architectures, business entities, business tasks, and application services. The framework is very modular. We can use those components that make sense at a customer, pick those, and we can also easily replace individual components of the framework, maybe with an integration with an adapter to some functionality that a customer already has. So maybe a customer has a super specialized authorization module, then we could easily replace our authorization module with the authorization of that customer. That's one of our tools. I'm going to briefly show that in the demo. I'll go over those quite quickly to get to the demo soon. So mentioned it earlier, RESTful has become quite important for us. In fact, we have customers that start using the smart component library because they have to either consume or provide RESTful interfaces. So RESTful is a standard protocol today for application integration. Today, when 2 applications need to talk to each other, the typical question is, do you have a Swagger or OpenAPI documentation for that? And all those are standards that help describing and building and testing RESTful interfaces. And our customers use that to either build new functionality, new interfaces, but it's also a frequent requirement that existing functionality from the application needs to be provided as a RESTful services. That could be for inquiries, for updating data, data exchange with other applications, and so on. So maybe providing a price calculation routine as a RESTful service to a web front end or a mobile application or whatsoever. We do not only provide the RESTful APIs or the ability to build those, we generate the OpenAPI or Swagger documentation out of the box. That allows also a suite of testing tools or allows other developers to generate clients that access our backend then based on many standard tools. When we build RESTful interfaces, you can forget everything that you learned about building REST interfaces with Progress Software, also SOAP interfaces with the web service adapter or REST adapter from Progress, where you have to build in Developer Studio and ProxyGen an application and deploy it, and very often pray that once you deploy it, it starts and it's available. None of that is needed. We just declare what we expose as a RESTful service in the code, and the rest happens dynamically at runtime. That makes it way more robust, way more flexible, and yeah, just doesn't fail as often as the standard methods of building these REST services and SOAP services with OpenEdge do. We recently released a couple of new features, or are soon going to be releasing them. One is that we now really support every bit of the OpenAPI 3 specification. We have recently added features of an API first design. That means if you are in an integration project and the other party is saying, hey, here's our OpenAPI specification, this is what you need to provide so that we can talk to you, then we can use that specification, which is typically a JSON document, to generate an empty backend implementation, and then you can start just adding the connection to existing logic and data into the existing API, but you don't have to deal with any of the API specifics. And we can do that also the other way around. If you need to talk to an RESTful API or REST API, you can ask the other party to provide us the Swagger tool, the Swagger file of the OpenAPI specification. Swagger was the old name of that tooling stack, and with version 3.0, the name has been changed to OpenAPI, but most developers still refer to the document as a Swagger file, even though when the name Swagger officially isn't part of the 3.0 anymore. So we can ask the other party for give us your Swagger file, and then we can generate an ABL client that's able to consume that API with a few mouse clicks. Well, when we're looking there and looking at legacy modernization, all of our tooling is based on object-oriented code, because we just believe that's the way to build more robust applications today. But as a matter of fact, many legacy applications need to use things like shared or global shared variables, and Progress doesn't support that in class-based code. So as part of the architecture stack, we do have support for all of that. So that means when a request comes into our PaaS environment, we're able to set values to shared or global shared variables, so that maybe the username that was provided in a client principal will be available in a global shared or in a shared variable in a database trigger, something like that. Here's an example of adding an API to a component. So all we need to do is we need to add those annotations. These annotations basically say this message should be exposed under this address /find customer. That's the relative address under the PaaS OE. We declare some mapping of parameters which are provided either as a payload of the call in form of cookies or HTTP headers or whatsoever, and some documentation elements that show up in the Swagger document. Then the Swagger document is built automatically, and we see that there are documents here or texts here that help the developer that wants to access this API to understand what it's doing. On the user interface flexibility side, well, we started the SmartComponent Library on the Windows desktop. Actually, the motivation for building the SmartComponent Library came from Progress releasing the GUI for .NET feature in OpenEdge 10.2a, 17 or 18 years ago. We started on the front end. The first two customers that we were building the Smart Component Library for, we're already having app server-based backends following the ORA standards, so that we didn't have to focus on the backend in the beginning. The backend was in kind of like the second phase of the development of the framework. But nowadays we equally support the development of web applications. We have put most effort into using the Angular framework and the GUI components from Progress Software. The reason for that is, well, Angular seems to be of the many web development frameworks the one which is best suited for large and complex applications, and typically OpenEdge is not used for small applications. So that seems to be a good fit. The Angular development, the development of the framework itself and the tooling is backed by some large players in the IT industry. It's Google and Microsoft, I think that Google has a lot of knowledge about the web, and Microsoft is probably, besides Progress Software, one of the few companies that are supporting pretty successfully developers since over 40 years. So that's just a pair of big industry players that I have a lot of trust in. Facebook offers web development frameworks, and I honestly don't know why I should trust Facebook for providing me with a web development framework for a business application. Mobile apps, we are using NativeScript preferably there. NativeScript used to be an open source product, mainly maintained by Progress Software, but Progress Software has given up the control on that. It's now maintained by a development company that does a lot of project work that's still actively maintained. The nice thing is NativeScript also supports Angular, so that we can reuse lots of components there. We've used with prototypes or sometimes components for other web frameworks like Razor and Blazor through our interfaces like RESTful. We support fully headless applications or customers building their own web applications. Every modern front-end framework these days supports the consumption of RESTful services. We have partners that are building application front-ends or frameworks based on the Smart Component Library. One that you may have heard of is build1. The build1 development platform relies very heavily on backend functionality provided by the Smart Component Library. Yeah, on the migration strategy side, we have customers that talk to us and say, hey, we want to migrate our existing ABL GUI or TTY into the Smart Component Library GUI for .NET client. That are companies that have strong reasons to stick on a desktop UI, because it might offer the best integration with other desktop applications. It keeps the technology stack simpler. Going into web always involves a much more complicated technology stack. And if you don't need the ease of deployment to any computer that has a browser, then doing all that extra effort of building web applications might not be justified. But we do have customers that come to us and say, hey, we know we need a web application front end, and either then go with our Angular front end components or go with a custom web front end. With customers that go then with a partner framework and others that go fully headless. That was a nice surprise. A couple of weeks ago, we started at the end of last year to work with a Dutch company, Ariza Navigate. They're building software for the management of loans and claims around loans and the like. They had the task to build a web portal which the customers could use. and they needed an architecture that supports the integration with their legacy OpenEdge application. Carl, the answer to your question is yes. So we started working with them late November, beginning of December last year, the key component of the SmartComponent Library in question there was the RESTful interfaces, they had a Swagger document which their portal developers had put together for, like, this is how the API has to look like. And then we implemented the API around that, step by step started adding additional functionality of SmartComponent Library. Normally, and that's the really nice thing, when a project has started and is going in a good direction, you have to run after the customers to ask them for a nice quote. Here it was the other way around. They asked us whether they could mention us in their in one of their LinkedIn posts to show what they are doing. So that was quite a nice surprise. So on the UI design, we support UI design in code, but we prefer actually UI designs in our repository database. The repository is a set of database tables, I don't know, 11, 12, something like that, in an OpenEdge database that's designed to store UI layout. In that repository, we can create reusable components, and we have our own developer tools, most likely wizards and designers to design those. Then there are runtime components that either consume that repository data at runtime, or we can also generate code. The rendering at runtime is not really slower than code, and allows also to be more flexible on what is really needed when. If customization options around that. So slowly but surely, we're going away from code-based UIs and more doing the database stored designs of applications. The reason for that is, also that source code is very inflexible when you need to make massive changes or lots of changes to UI components. Well, every ABL developer knows how to manipulate data in an OpenEdge database. Being able to provide something that's easy to modify in a batch has also proven a couple of times to be a big plus. So this is now an example of our Angular UI. The main styling here with the menu on the left, the blue bar on the top, and the gray bar in the bottom, and the fact that in the middle we're having a floating window within the browser window, that's all fully customizable and can very easily be replaced by any CanUI or other Angular components. Like I said earlier, we typically use the CanUI components, but every now and then we use other Angular components or build Angular components ourselves. The key functional or the key behavior of such an application is very similar to a desktop application. And so I would use these UI components typically for what I would refer to an application in the browser. I probably would not use that grid and a floating window and that menu when we're building more something that I would refer to a website or a portal, because then you typically would want to have simpler and maybe even more intuitive to use components, and you would probably not have a use for a tab folder and being able to show two windows side by side, etc. So when we start a migration or modernization project, we can look at the existing application and start with that, and step by step add existing features of the SmartComponent Library, or we can migrate code. So now we're going to look at migrating code. I want to get away from fully manual migration of existing applications, and whether we have a semi-automated or an automated depends a lot on existing applications. If an application is very standardized, then the automation ratio can be much, much higher. If we're looking at an application and structure that we know very, very well, like ADM2 or Progress Dynamics applications or something like that, then we know which code where has which role, and then the analysis part in the beginning of a migration project is much, much lower. And typically these migration tools, they are based on analyzing of the existing source code. We maintain ProParse for that. ProParse is an parser for ABL code. ProParse understands ABL code in a very similar way as the compiler does. So it understands keywords. It knows what a keyword is. It knows what a database table is, what a variable is, etc., and presents us that then in a structured fashion in a tree, an abstract syntax tree. And once this analysis is done, it's just much easier to get an understanding about the existing source code than if we would be doing that straight from the source code. These tools, they are adaptable, and the truth is need to be adapted to the coding style used in the existing application. And then we are able to discover relevant business logic. We can decide or make educated guesses. What is business logic? What is UI logic? We can combine business logic that we find in multiple screens dealing with the same set of database tables into single business logic objects, like maybe a validator class for every aspect of a customer record or something like that. We can transfer UI logic into cross-platform UIs that allow us to use a migrated form of the business logic, then both from web applications and from Progress GUI applications, and probably also from a mobile application. Yeah, we've done quite good experience also with migrating from various legacy developer frameworks. Mentioned the ADM from Progress. ADM2 is certainly a better starting point than ADM1, but also that works. Progress Dynamics works. We've done that with a DWP framework and ProShield. So, like I said, foundation is the abstract syntax tree provided by ProParse that provides us the independency from the coding style, abbreviated keywords, and all that stuff. Typically, the older ABL code is, the more synths have been used when writing it, and then relying on ProParse has a lot of value. We have no problems with include files or nested include files and preprocessor parameters and all sort of that. We can understand GUI, TTY, WebSuite, GUI for .NET code in equally. We do a static code analysis. That means we do not need to execute the procedure or the window that we're looking into. We're not walking the widget tree, and that also allows for a much higher automation. If we would be relying on walking the widget tree, for instance, then we would certainly be much more limited in working with TTY applications, because most of our tooling is having a GUI front end or is headless. And through the combination of what ProParse provides and the tooling that we've built on top of that, we have a pretty wide understanding of ABL specific elements like scopes for variables or buffers, transactions, etc. So we know when two internal procedures are talking to a record, whether it's the same record or whether they're different buffers, different scope buffers, and that's something that we can then put on the plate when we're deciding what to deal with that. We understand frame phrases. So when we're looking at existing GUIs, the frame phrases are sometimes quite challenging because they magically behind the scenes inherit things, definitions from the database, or in the code elsewhere, multiple frames can be combined and stuff like that. Not all of these rules are documented, but we think we have a pretty good test experience there that we understand quite a lot of interesting concepts. And if not, then well, then we'll have to extend our tooling. So let's start with one example. So it's a very simple TTY update editing screen. And the nature of update editing, I'll show the update editing statement in a second, is, well, it's basically like a big loop that ends when the user presses the go key, or saving all the changes. And until then, the loop is iterated for every key that the user presses. And then based on in which field the focus is, the cursor is, we know whether it's a value change or leave of a certain field. And yeah, well, in TTY applications, a lot of validation code is in these update editing statement. So let's look at that. So I'm opening one of the samples. And just to show something new, I'm using VS Code as my development environment. Here we go. I've put together the frame design in the app builder. You can combine all sorts of styles together. So here's the update editing block. So we have the update statement and the read key statement to get a key that the user presses. And then typically you have blocks in a similar form like that. They're not all done the same, but many of these update editing constructs have followed what was in the early OpenEdge or Progress documentations, something that looks at which field do I come from, or is go pending, so did the user press the F key too recently, and then we look at the values of screens, and based on that then look at records and see whether we can find the record and stuff like that, validate the data while the user's in the form, display values, etc., etc. And some of these update editing blocks have thousands of lines of code, and that's just relevant code when migrating the UI. So what we can do is we can go into parts of our tool, and the GUI side of the tooling is mostly for demo purposes. When we really set up the tooling for an actual migration project, we very often build scripts and try to automate it a lot. But in this tool, I'm going to open that program, and what is happening, it analyzes the source code and it looks for frames. For us, typically frames are the building block of certain UI components. We have other tools that look for browsers or tabful, whatever. There's only one frame in this program. I can look at how our parser looks at this program, and so here is the tree view style, and looking at the tree view from the abstract syntax tree in an actual tree just helps us to see the code in the same way as a code parser, and then think around that. Okay, so there I have the name of the record I'm dealing with, and what do I have around it? I have a display statement, and that has a form item that's referencing a certain field. And so using that, and I can also do it the other way around, I go on the on a statement or select a statement, and I can locate that statement then in the tree, and yeah, just match the abstract view of the code with the actual code. And so in this tool, or what this tool supports me with, is I can use this to generate a business entity that would be qualified to provide the data that this program needs. So I'm going to do this. I'm going to create a new business entity. It has found those tables in that program, or in that frame here in particular, and yeah, it asks me which one is the leading one based on the order in which they are accessed. It's guessing it's the customer table, and basically now I just need to pick a folder. This X update editing generates the business entity into that folder. That's gonna save it there and open it now in our business entity designer. It's the graphical tool which we use to build business entities. Start in the background. Now we see a business entity that knows which database tables it's going to be talking to, and has all the fields from the three tables. And I think country name is the name of a variable that has been referenced in the screen too. So I can generate a business entity from here. I could make modifications there. I could change names of fields, for instance, if the database uses well, ugly abbreviated field names, then we can work with those. And after the source code has been generated, it's automatically opening in the development environment of my choice, which here is still configured to use Progress Developer Studio. My routine when I'm programming, I'm typically using VS Code more and more for writing code, and I use the Developer Studio mainly only when I actually have to build GUI for .NET layouts or app builder layouts, because VS Code is just a tool for writing code and not any GUI designs. So this business entity, I could use this now and see that it's returning some data. Before I do that, I'm going to do something else. I'm going to go back into the ProPath tooling, and that has here some wizards that are loaded. These wizards are not hard-coded into the tool. They are injected through plugins. So through these plugins, we can then also build customer-specific variants of these tools that just work much better with the particular coding style of a customer. So that has now found an update editing style statement, and now I can convert that update editing statement into code that we can use for validation in a business entity. So that's a very particular migration tool here that looks at the update editing statement, understands which business rules are there and which fields are validated. And what I need to explain to this tool is I need to explain into which previously generated business entity I want to build that. The reason for that is that within the business entity, we support changing field names. So if the customer number field in the customer business entity would be a very abbreviated field name in the business entity, we could give it a more meaningful name so that in the future development with that database table in the application language, the application schema, we're using something more meaningful. So that's why we need to know to which business entity build that. So when I've done that, it shows me now the migrated result as code that we can copy and paste into a business entity. So if I compare this now, So if customer name equals empty string, that's something that we find here too. We know from the structure that we're validating the name field. So here's a message and the next prompt with the next block statement, which is a very typical construct in this update editing statement. So we know, okay, that is an error message that we need to report back in the form that we do with ProDataSet. So we add it to the error string of a ProDataSet, etc. Then the next block is we look for the sales rep. The code that was referencing the input before is now accessing the temp table fields from the business entity other changes, and that works bidirectional, so we can also update the values there. And the same for the other blocks. So I can now take this block here and just copy and paste that into the business entity. What was that? Into the business entity in a more automated fashion. We could actually be automatically, but for the demo purpose, a little bit manual work is more helpful. So that's all the changes I'm doing. What I do here. So I said I want to expose this as a RESTful service. So what I now need to do, I've taken some notes just to be a little bit faster here. So I'm taking these annotations and I'm adding these annotations to the business entity, and I'm adding this interface to declare that this business entity should actually be exposed in a RESTful fashion. So, and with that, I have pasted in validation code that was migrated. I've added the RESTful annotations, and to get this business entity exposed as a REST service, I only have to delete a cache file of definitions which we maintain to speed up things and trim the app server. And that's all the deployment I need to do. And then I'm going into a web browser. What's there? Into the Swagger page. I'm logging in because our backend is typically authenticated using one of many options. While I'm doing that now, the pathway is restarting and shows the Swagger document. And under the SCL demo tag, so that's part of what I described as the API, the tag should be SCL demo. And in another file, we're providing then the documentation that SCL demo should be described as SmartComponent Library demo with a link to further documentation. So that would be how we would be describing then to a consumer of this API specific bits. So I can use this business entity now to fetch a record as a JSON document. So that has been also the links between the tables all taken from the existing source code. And I'm going to copy the data from this record, using then Swagger to test another operation. I want to use the patch operation to update the record. So I want to update customer number 1 and put in this data, and I'm going to try a non-existing sales rep because we have validation based on the sales rep. I'm going to execute that, and I'm not getting the message that the sales rep code is not valid because before that I'm getting an error message that I'm not authorized to update the field city. So within the framework we have authorization, and part of one of the authorization schemes we have is field level authorization, and I'm not allowed to update the city of a customer. So when I change that and remove the city from the update request, then I'm getting the message, please enter valid sales rep code. XYZ is not a valid sales rep code. So if we look at the legacy program, that is exactly the error message that we had here. Well, when I would be adding it to a valid sales rep, then yeah, I would be able to make the update. So that's part of what we have refactored here, the validation that was part of an update editing block. So let's get away from that. Let's get into what we deal with the actual UI layout. That's, like I said earlier, more a GUI concern than a TTY concern, because very often TTY layouts don't fit that well as a starting point for the UI layout of a web page or web application or a more modern desktop application, but it can also be used. But most of the time we're doing this with GUI applications. And one thing which would be fairly easy would just be reading the frame statement, say, hey, that's it. We generate a frame with exactly the same orientation of the fields, but that wouldn't be as valuable. So we can understand the UI design, and we move the UI layout first into a meta structure, which is basically just a set of temp tables. And then we can use ABL code to decide what we do with that. And I'm going to show that on the example of a very common pattern used in GUI applications, the lookup, or others call it the zoom field, which is typically you have a text field or a numeric field for a key value that has a leave or value change trigger. Then you have a button typically very close to it, and probably a description field right off the button. And in more modern UI frameworks, a lookup is typically one complex component, one specialized component. So during this migration of the UI layout, we can go, we can detect that. Works also with to from fields or with date and time fields and whatever, and replace them with a more modern complex component. Also, this is customizable through ABL-based plugins, we can. That's then something when we go towards the web might be relevant. We can optionally then also translate a pixel-based or a column and row-based layout into responsive layout definition. It's really just some looking at what is positioned where and how would it fit into columns and blocks of fields, and based on that we can derive then a pretty good starting point for a responsive layout. So that's the UI that I'm starting with, that I'm gonna use. So we see that we have two tab pages here with some fields from the customer. On the second page we have the shipping address of the customer, and we do have for the country field a lookup seen here by the three components: the key field, the button with the three dots, and the description field. And we have a similar construct for the sales rep field in the bottom. We have rectangles to group the fields. In the Progress GUI, a rectangle is really just a box drawn around some fields, but the fields are actually still parented in the same frame as the rectangles. In more modern UIs, rectangles would be replaced by group boxes, which then becomes the actual container for the fields, which is also for responsive layouts quite powerful, because then we have blocks of fields that should be wrapped in combination. And with that, so we can transform the fields in the frame now into multiple group boxes. So when I look into that, I'm going to use the same tools that I started with, because that's just a graphical tool to represent, to analyze our frames. So now this tool has found 3 different frames in the program, which is very common for ABL-based tab implementations. If I look at the customer frame, then we see all the widgets that we found on that frame. And if we pay a close look to that, we will see that the first column in this grid is indicating whether or not it's selected. And there's the button for the lookup of the sales rep and the button for the lookup of the country, which are not selected. And on some of the fields, country and sales rep, the tool has made the decision to replace them with previously registered components. Those are components which are stored in the UI repository, lookups for the country, lookups for the sales rep. So let's look at how that works. So as part of this screen, when the screen loads, we're loading a class that implements the frame migration preprocessor, because it's active before we do the actual migration. And basically, after we have found all the widgets in the frame, we now call into this class or into specific methods of this class, and that allows us to modify the data. And so this is all pretty straightforward ABL code. So there we see the block of code here, a simple for each and attempt table that says, well, in order to know whether something is a lookup, we need to have a field, and then we look for a button which is based on its column and row close enough to the field, and then it becomes our candidate for a lookup. It is not yet 100% sure that it is a lookup, because just looking at the buttons is not enough for us here. We can also look for the description field, also by its position on the screen. Then we process the triggers. So why do we process the triggers? Well, by here we go. Because if a field is a candidate for lookup because it has a button next to it, then we look into the trigger code and we see, okay, well, if it has a find statement with an equality on the screen value, and then some display states, then we're pretty sure that this looks very much like a lookup. So we use the UI layout and the source code in combination to really decide whether or not we make it a lookup. So when we look further here and we process the triggers, then we look in the trigger block for a find statement. Then we look for the record name node there. We look for an where with an equality. And then we loop through this, and based on that determine the key field. And if at the end of this journey we still think this looks like a lookup, then we see whether we have a lookup in the repository stored for that, and then that's the component that we propose here. If this tool would make a false guess, then we could still change it here. Many of these fields are updatable to allow a developer to make changes here. Then we have various buttons here to generate various components or various types of components out of this. So here we use a repository viewer that generates an object in the repository. And I'm gonna open that. I've previously generated that to save a little bit of time. So I'm going to open that component, and that's now our own designer for the objects. The object has a name and is stored in a what we refer to a product module. That's like a virtual folder in the repository database structure with attributes on the object itself, with a graphical design of the converted viewer. So here we see that now the lookup, or both lookups, are now a single component that includes the button, and yeah, that is used on the component that has been migrated from the window using another tool. We see that on this window we have now the one frame and another frame and some components for accessing data. I can launch this tool from here. It's now it's a desktop application. I could also launch it as a web application. And we now see that this lookup is actually behaving as we'd be expecting from a lookup, or like that. Oops. Well, no demo without an error. So let's now look at the next, what happens with custom trigger logic. Because many applications, well, like it or not, have lots of business logic in triggers. We can migrate the trigger into specific GUI for .NET or TypeScript triggers for ABL code. We have an API that we can then be used to make to provide properties like screen value and sensitive and hidden and visible and the like that are typically appearing in ABL code in those other UI technologies. That's something that we've been using for a while. In the more recent times, we've been more moving towards migrating the UI trigger code in a way that it becomes a server-side event handler. It's called application service, which also allows cross-platform use. Well, sometimes we need both. The benefit of the server-side cross-platform trigger is, well, it can be reused. It's the trigger execution is closer to where the data is, and very often the UI triggers need data. But the front-end trigger is closer to the UI component. So depending on what the trigger does, we are using the one or the other approach. We can use those for handling events such as value change or leave or click on a button, typical ones. Yeah, then we call into the backend and provide a way how the backend can manipulate the UI. The typical forms of manipulating the UI from a trigger is, well, you change field values, you enable disable fields, you view and hide fields, you may be changing the styling, the background color, or controlling the focus, etc. We call into these services then, or these event handlers, with providing a data set. And an object structure as a response with UI manipulations. So let's look at an example. So that's a well, nasty, not pretty, but I think very often in a form like this. Trigger, you find a customer based on a field on the screen, whether you use the input keyword or screen value or input value, it doesn't matter. Whether or not you find the record, you display some values, you blank out other values, then the display fill of blah, 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 that just puts the customer number here 7 times and it's other into the instructions, just to have some form of calculation here. Then we change the background color to red and set the instructions field to not sensitive. The carrier should become invisible. So, that can be turned into server-side event handler. I think I explained the input earlier. We'll see it in the sample. Architecture-wise, the server-side event handler would be referred to as application services when one would follow the onion architecture, where with the domain model, which is typically represented by business entities, domain services, which are business tasks, and then the application services. And the closer we go from the, or the more we go from the inside to the outside, the more specialized we become for a typical user interfaces. So a business task as a domain service typically would be written in a way that it could be reused in different applications. An application service, that's where you generally say, I'm not expecting that this is going to be reused. So the same leaf handler, whether in a mobile phone application with a very small device or in a much larger UI, will be reused. We cannot plan for that, and it might not be feasible because of the number of fields and so on. So let's look into that. So I have so here's some prepared samples. So it's a form with a viewer, and in this viewer we have as a custom field. So this viewer has been generated based on an ABL frame with a trigger logic. So I can execute this here, and I'll see now that when I update the fields and change the values, something changes in the UI. So the instruction fields now is 7 times the customer number, becomes disabled. The carrier field has been hidden, and the focus has been moved into the terms field. And, when I use a different customer, that happens. And when I use a customer which is not there, then various values are being blanked out. So that's done by calling into logic on the app server, on that backend component. And the nice thing is, if I now run the same repository layout within our Angular web application, the behavior will be the same. So I update that and pick a value. The instruction fields now 7 times the 1. The carrier has been hidden, focuses in the terms. So we have defined just a response structure that can be understood by a GUI for .NET based desktop application and a browser based application, and that's executing the trigger. So now let's look into the trigger code. So here's the method that contains the same find statement for the customer. It's not using the screen value of the e-order custom, it's using the value of the temp table that has been provided as the input to this. We're having the same if available construct, assigning values into the temp table as the substitute for screen values based on the database records. Here's our funky fill of the custom by 7 times. And for the controlling of the UI, we say, okay, well, the instructions field should be getting, well, we're not doing the nonsense with having a specific color in the source code anymore. We're using named styles. So as part of the migration routine, we say, well, you encounter BG color 4, then turn that into a name style called error, because this name style can then be understood both by the desktop using the Inflogistics app stylist and Angular using cascading style sheets. Not sensitive, this should not be visible, and the focus goes here. So if we compare that with the original code, the structure is the same. It's basically just how we provide the certain instructions. So we're not setting widget attributes directly, and that makes it fairly easy for us in the migration routines to maintain the same logical structure, nested if then whatever finds for each is whatever data access, and so on and so on. And the interesting bit now if we look at this method here, this suddenly became unit testable. So I can now write a unit test that reads a dataset content from an XML file, changes a screen value to 1, and then calls into the same server-side event handler logic, and then checks whether the result is that we're having lift line skiing in the screen value of the customer name field, and whether the field instructions is now styled as an arrow field. So that's a nice side effect of turning that into backend code that is not dependent from any specific form of the UI anymore. It suddenly becomes unit testable. So that was that, the unit testing bit. And then we can go even a step further within the backend code, both now in this server-side event handler, but also earlier in the validation code that we have migrated out of the update editing statement. We were still having direct access into the database table, and following the principle of the OpenEdge reference architecture, we probably prefer to reuse data access from specialized components, business entities, and dataset classes. So the reason why we first start with keeping in the database access is when you start a migration project, typically with a proof of concept, and you look at such a UI, you very quickly need 20, 30, I don't know, whatever number of business entities for master data or control data tables in the database. And so even if we can generate a lot of that very quickly, but still that means in order to get the one screen that we want to start with going, we have to build all that mountain of other stuff around it. We accept that in the beginning we have here and there some direct database access, and then maybe in the later step replace it with our ORM model. And that would then look like this. So we replace, or we, depending on whether or not there have been database buffer definitions or not, we then replace the code with creating instance of our dataset models. A dataset model is our object relational mapper, and then the find statement with a filter instruction to that dataset model in the bottom there, and then when it's available. And now we have both abstracted the trigger code from the UI, but also from the database. And, so that gives them the biggest flexibility for dealing with that. Good. That was the last bit of my demos. Seen a couple of questions coming in the chat. Lutz, did you keep an eye on those?
Yeah, we have two questions from Wim, which needs an answer. So the first one was about what tools we use when designing REST APIs, or what do we recommend?
Well, the SmartComponent Library. No, that's a good question. That is a question, Wim, I don't have an answer for you, because when we deal with RESTful APIs at customers, either there's an existing Swagger file that we need to work with that somebody else designed for us, or we build business services in the SmartComponent Library, and then the API specification is derived from the actual code. So when we say we do API first backend design, then those API specs have been provided typically by others. typically, in those other worlds, it's done in a very similar way. So when we expose a business task and say it has these input-output objects and data sets, then based on that, we turn that dynamically into a JSON schema, and that's the most important part of that API specification. When other people build similar backend services in Java and .NET or whatsoever, or Node.js, the same happens. You build an application that exposes methods and takes input-output objects. Then based on that, these toolings automatically provide you with a Swagger file. I don't know if somebody uses an UML designer or something like that to start really in the abstract world and build an API specification. I don't know. So what's this other question? Yet another front-end Flutter by Google. That would be a question for our web developers. I haven't spent any time with Flutter yet. I don't have any opinion about that. Carl, do you have an SQL Angular sample application? Well, Carl Verbiest from CCE, they're using the SmartComponent Library. So what we can provide you is the Angular application that maintains the data in the SmartComponent Library database, which is basically the alternative to the GUI for .NET application doing the same. So Carl has another question here. You used TypeScript earlier. Slides mentioned NativeScript. Are using both? Well, TypeScript is not a replacement for NativeScript. NativeScript is a cross-platform mobile phone app development platform that has development tools and runtime components and so on. Within NativeScript development, you also can use TypeScript as the language for the client-side code. So it's not TypeScript or NativeScript. It can be TypeScript and NativeScript. But NativeScript can also just use JavaScript. And but there, I'm now leaving my comfort zone. Yeah, I think those were the questions. If there are no other questions, then let me mention a few events in the near future. So first one next week, Wim, I'm expecting you there. The Baltic PAC is having a conference I think it's Wednesday next week in Tallinn. I'm going to give a presentation there too, but many others are going to be there too. I think they're expecting over 100 attendees at that conference. In 3 weeks or so, the German Progress User Group is conducting a workshop on using VS Code for OpenEdge. The workshop will be conducted by Gilles Quéré, who's maintaining the OpenEdge plugin for VS Code and the language server. So nobody knows that better than he. And I'll be supporting him both for, if somebody would have language problems, but I'm having, I don't know, 2.5 years of practical experience using VS Code for OpenEdge development. So with the different perspectives, the person who builds the tool and the person who uses the tool. So we'll be doing that workshop together. The week after, the UK and Ireland PAC will be having its summer conference in the neighborhood of Birmingham, I think. Well, mid-June, the European soccer tournaments, UEFA Euro, the UEFA FIFA, no, UEFA Euro is starting, and as always, Consulting Work will be conducting a prediction game for customers, partners, friends, and families. And we'll be doing further webinars over the summer. The dates are not yet announced, but I'm guessing there will be one end of June. And then in the fall, it's PAC Challenge time. PAC Challenge on the European side will be in Prague from the 18th to the 20th of September. And 2 weeks later, there will be the PAC Challenge in Boston. from the 29th of September to the 2nd of October. Good. And if there's still no question, then I'm coming to the end. Thanks for your time. And well, if you have any questions, don't hesitate to email me. Otherwise, wish you a nice evening. Thank you.